Okay, so we're all pretty used to thinking of AI as a tool, right? Something we give a command to, and it gives us an answer. But what if the AI didn't need our commands? What if it could pursue goals all on its own? Well, that's the next frontier, and it's called Agentic AI. These are autonomous systems that don't just follow our instructions, they actually get things done.
And this really is a fundamental shift in how we think about this technology. A true agentic AI can see what's going on, it can make a plan, it can act on that plan, and, this is the crucial part, it can learn from the results to get better next time. It's the evolution of AI from a passive tool you constantly have to micromanage into a proactive teammate that's actually working right there alongside you.
Here's a good way to think about it. A standard large language model, that's like having a brilliant but totally forgetful intern. It can do an amazing job on any single task you give it, but 5 minutes later, it has no memory of what it just did. Agentic AI, on the other hand, is like getting that self-managing project manager. It remembers the goals, it manages its own resources, and it learns from its mistakes. But to get there, it has to overcome two huge challenges. It needs to develop a real memory, and it has to learn how to evaluate its own performance.
So if this stuff is so powerful, why isn't it running every part of our world yet? It's a fair question. Well, as we move from that exciting vision to the practical reality, we start running into some pretty serious and often hidden hurdles that are stopping it from being used everywhere, especially in high-stakes business environments. And this really gets to the heart of it. There's this huge gap between how these things perform in a lab and what it takes to succeed in the real world. Get this, a massive 85% of companies are already experimenting with generative AI. But most of these agentic projects, they completely die after the proof of concept stage. They just can't handle the messiness and complexity of reality. One of the biggest and frankly shocking hurdles is cost. The costs are all over the place. When researchers tested a bunch of different AI agents on the exact same task, they found a 50-fold cost variation, even for agents that got similar results. That is like getting 2 quotes for the same job, and one is for $10 and the other is for $500. No business on earth can operate with that level of wild unpredictability. And it's not just the cost, it's reliability. So let's say in a single test run, an agent gets it right 60% of the time. You might think, okay, that's not terrible, right? But here's the kicker. When you test for consistency over just 8 runs, its success rate absolutely plummets to 25%. For any serious business application, that's a total non-starter. You can't run a company on a tool that only works 1 out of every 4 times you try to use it. No way.
This quote really hits the nail on the head. There's a fundamental misalignment. For a long time, we've been optimizing these agents for simple accuracy. We've just been asking, did it get the right answer? But businesses, they need to know a whole lot more. They need to ask, did it get the right answer, reliably, securely, and without breaking the bank? We've been measuring the wrong things all along.
So, how do we fix this? Well, the first big solution is to completely change the way we measure success. And this brings us to a new and much more comprehensive framework for figuring out if an AI agent is actually ready for the big leagues.
It's called the CLEAR framework, and it was designed specifically to bridge that gap we talked about, the one between the lab and the real world. It goes way beyond just checking for the right answer. Instead, it creates this multi-dimensional report card for an agent, focusing on all the metrics a business actually needs to see before they can trust an AI with critical tasks.
So what does CLEAR actually measure? Well, it asks the simple questions that every business needs answers to. C is for cost. How much is this thing going to cost me to run? L is latency. How fast is it? E is efficacy. Does it, actually work? A is for assurance. Is it safe? Is it secure? And R is for reliability. Does it work every single time? This gives you a true holistic view of whether an agent is actually production ready.
All right. So CLEAR gives us the right yardstick to measure our agents. But there's a second, equally critical problem we have to solve: memory. The large language models that power these agents have what's called a finite context window, which is really just a fancy way of saying they have a very, very short attention span. And that fundamental limit is what stops them from being able to reason through long, complex projects. Now, the old way of trying to give AI a memory was, well, it was clumsy. You'd have these separate, fragmented modules for short-term and long-term memory that were basically bolted on after the fact and had to rely on a bunch of fixed rules. The big breakthrough, proposed by a framework called AgeMem, or agentic memory, is to create a unified system where the agent itself is in direct control of its own memory.
It's no longer just a passive database it looks up, it's an active part of how the agent actually thinks.
So here's how that works. With agentic memory, memory isn't a thing, it's an action. It's a set of active tools. The agent can literally choose to add new knowledge to its long-term memory, that's its LTM, or it can update something it already knows. It can retrieve a key fact into its active short-term memory, its STM, or it can filter out irrelevant noise from what it's working on right now. Memory stops being this passive thing in the background and becomes an active skill the agent can use.
And what's really cool is they developed a pretty clever way to teach this. First, the agent learns how to build its long-term memory, basically figuring out what's important enough to save for later. Then it learns to manage its short-term memory. It's almost like it's learning how to focus and ignore distractions. And then finally, in the last stage, it learns how to use both systems together, seamlessly, to go after those really complex problems.
So, when you boil it all down, the crucial point is this. Building a truly capable AI agent, one we can actually rely on, means solving two deeply interconnected challenges.
First, we absolutely have to measure what actually matters. We've got to use holistic evaluation frameworks like CLEAR that look way beyond simple accuracy to things like cost, reliability, and safety. And second, we have to build them differently from the ground up. We need to treat memory not as some passive database, but as an active, unified skill that the agent learns to control, just like that AgeMem framework proposes.
You see, solving these two challenges, intelligent evaluation and intelligent memory, that is the path forward. That's how we get Agentic AI out of the lab and turn it into a reliable tool that can literally transform industries. And, it leaves us with a pretty fascinating question to chew on. Once an agent can perfectly remember everything it's ever learned, and it can accurately measure its own cost and reliability, what are the uniquely human tasks that are going to be left for us?